Hi, so yeah, welcome to this channel. This is going to be a series on AI. But we are going to look at the data-driven aspect of AI, which is we're going to, in the long run, we are looking at the whole ecosystem of data analysis, data science, machine learning, deep learning, like that within those ecosystems. So that's what we are limiting ourselves to. So this AI series. So I'm going to be teaching you several aspects. I mean, several modules, frameworks, and so many other things. But this is AI series. So I'm going to start with NumPy today. NumPy. So there's going to be a series on NumPy. Then we'll move to Matplotlib, Seaborn, and so many other things that will enable you. There are tools that you can use effectively to be able to build models that you use in the process of building models, Scale-Learn, TensorFlow, also like other platforms like ChatGPT platform, their APIs, then using what is called Hugging Face, and so many other things like Google, Gemini, stuff like that. So a lot of things we are going to really look at, but the fundamental or the foundations are things we are going to look at right now, which we are going to deal with. Going to deal with how to use the basic tools first. Like when I say tools, I'm talking about the model. I'm talking about the modules. So NumPy is one of the fundamental modules that you just have to know. Then we're going to move straight forward to NumPy right now. Now, I'm going to use Jupyter Notebook because it's very friendly, user friendly. When I mean friendly, I mean it's user friendly, and there are a lot of things you can do easily compared to other IDE or code editor. So to do that, or to if you have a PyCharm, or you have an Anaconda, whichever anyone you want to use. If you have PyCharm, I'm using PyCharm. So if you have PyCharm, you just say start Jupyter Notebook. So let me run it again because I've stopped it. Okay, so start. If you want to install Jupyter Notebook, please remember it's pip install Jupyter Notebook. You understand? So you install it. I've already installed it. So or pip install notebook. I think that should be pip install notebook. And check it. Pip install notebook. Just check it on their website. Pip install notebook or pip install Jupyter Notebook, whatever. So it's just install. So after installing it, just say start Jupyter Notebook. So immediately you see it's going to start. So you see now. So it's running right now. Now, also while it's running, you see it's coming up now. So it's come up now. So all the files in my Python PyCharm that by the side, you see it. If you check it, you see it here right now. So all the files, they're also showing that place in Jupyter. So what I want to do is I will show you NumPy. I will talk about NumPy, but NumPy is actually a kind of a numeric Python. It's called numeric Python. That is the full meaning of NumPy. So what it does is a package or a module in Python that is used to undo numbers or numerical values. It form of, you can call it tensor, but I'll show you more about that. But before you use NumPy, you have to install it, like pip install. So pip install. Make sure you upgrade your pip. So if it's outdated, make sure you upgrade to the latest upgrade. Then you now use pip install. Pip install what? NumPy. So this is how you install it. Then you enter it, and then it starts downloading and then install. So the other ways of installing that, you can go to file here, go to settings. When you get to settings, go to project, whatever project is, call it. So go to Python interpreter. Then you will search. You says plus here. So there's a plus here right now. Plus. So if you click this plus, you search for NumPy. So when you search for NumPy, you see when I click NumPy, it's going to just click the install here. So install. So there's the GUI way. I'll call it GUI way. But the other way, which is pip install, I prefer this pip install. Just run the command, it starts running. So I've already done I've installed NumPy already. So if I want to install it again, it's going to tell me that system requirements satisfy. So pip install NumPy. So if I run it now, it's going to show me. Make sure you're connected to internet, please. So it's going to tell me that the requirements, the system requirement is already satisfied. Requirements already satisfied because I already have NumPy in my system. Okay, so that is it. So I'm going to move straight to Jupyter Notebook. Jupyter Notebook runs on browser. You understand? I run some browser. So I already have Jupyter Notebook here right now, which is Start Jupyter Notebook. That is where I started it. So I'm gonna open a new file. Let me just call it NumPy YouTube. Just call it Python 3 here. See, NumPy YouTube. Let me just call it NumPy YouTube. That is the name. So let me name it here. So my YouTube channel, NumPy YouTube. Let me just say YouTube NumPy YouTube. So YouTube NumPy. Let me just put. I don't think it allows for space, so take note of that. So rename. So it's YouTube NumPy now. So that is it. So this Jupyter Notebook, I guess you should be able to use it. So if you run this, your code cells, like code cells. This cell. So you can create more cells, and if you want to do, possibly I might have to create a new lectures on, let's say, new just standalone lectures on how to use Jupyter Notebook, but I'm not going to teach it in this lectures because it's specifically pinpointed at NumPy. So let's look at NumPy right now. So NumPy, let me quickly go to this place. So they have their documentation in case you want to make reference to documentation, numpy.org. You can just check it here. A lot of things you can gain from this place because this is core foundational Python package that is used in many, in fact, many other packages are built on top of NumPy. So they are built on top of NumPy. So you can see the logo here, which shows like a kind of arrays of numbers. Like we have different arrays of numbers. So NumPy is numeric Python, as I've said before. You can also go to w3schools.com. It's one of the website that is very good for beginners. They can use it to learn very fast and in a simplified way. So I'll also be following this documentation here. And also, let me quickly look at when we say arrays. In our previous videos, we talk about list. You understand? List is just a collections of different either numbers or data type. Data. You understand? Collect them and store them in one single variable. That's a list. So if we want to do list, we can multiply two lists together. We can do divide. We can do multiplication, addition. And so many other operations, arithmetic operations on them. But list is not very fast in the way it's executed, because when you go to massive numbers, massive arrays or collections grouped together, massive, they can be just a single column vector, like a kind of linear. Let me just show you here now. So if you go to Google right now, just type various tensors. So it can be something like this. This is scalar. This is scalar now. This is vector. Hey, it could be like this. It could be this matrix. This two-dimensional matrix. This is not this is dimensionless. This is not scalar. Is not it doesn't have a dimension. This is one dimension. It's also called 1D tensor. This 0D tensor, there's no dimension there. This 1D tensor, and this is 2D tensor. 3D tensor will look like when we say 1D tensor, just like a linear. It can be vertical like this, it can be horizontal, whatever. It can be row vector or column vector. So that is it. Then matrix is two-dimensional, so it has length, breadth. Let's say length and breadth, for instance, or you have XY axis. You can represent in a two-dimensional vector space. Now, moving to three-dimensional vector space, let me just show you. Three-dimensional vector space like this. So three-dimensional vector space, you can represent it in a kind of XYZ kind of axis. That is three-dimensional. We have other higher dimensions like 4-dimension, 5-dimension, 6-dimension, like that. They can be applicable in advanced engineering, advanced mathematics, applied mathematics. You understand? So that is so numbers can be values, or data can be arranged in form of tensors. These are all called tensors. You understand? This is a tensor, this tensor, this is zero-dimensional tensor, this one-dimensional tensor, this two-dimensional tensor. Okay, so these are ways. Okay, look at it now. Let me just show you here. This is just one, your counting number like 1, 2, 3. That is scalar. But when you have it like this, it's called vector. This is called matrix. This is tensor. This 2-dimension. This higher dimension. This 2-dimension. This is more like 3 dimensions. So we have higher dimensions. So NumPy can undo all those things. And sometimes you want to this tensor now, or this matrix want to be multiplied with another matrix. This tensor want to be multiplied by another tensor, either addition, subtraction, divisions, like that. So there could be a lot of arithmetical operations or algebraic operations you want to do on tensors. So as a result of that, you will have a lot of limitations. So NumPy is invented or is developed to be able to handle those kind of operations. You understand what I'm saying now? So I'm just trying to create a background overview of what NumPy is, so that you know why we are doing it. Sometimes the images, your images, you see, they can have length and breadth. Like if I snap myself now or take selfie now, for instance, and you see, I can be represented in, because it's a plain representation, so I can represent myself in form of a length that's in a two-dimensional space. But beside that representation, there could also be something like color. I want to represent my colored image of me, so that would be color value could make it three-dimensional. So if you want to convert an image in a computing, image will be converted to numbers. You understand? Videos will be converted to numbers. So to be able to now manipulate those conversion and to use those conversion, so you need to be able to have a package that handles numbers, large amount of numbers stored in a single variable, or that represents a data, a particular data. It could be video, it could be text, it could be a image, like that. So this guy, which is NumPy, came to the rescue to be able to manipulate and represent numbers in form of lists, massive two-dimensional, three-dimensional vector space, like that, or even higher dimensional vector space. Okay, I'll talk about TensorFlow later, but not now. So let's move back. I believe I'll be able to create a good background foundation for our furtherance of NumPy. So let's go back to NumPy. So if you want to do NumPy now, first of all, I said you have to install it. If you check, it's very fast because it's written in C or C++, C and C++. So it's very fast in execution. That's why it's being used generally. So you can just read stuff here like that. But let me move straight to Jupyter Notebook. So you have this. Yeah, after installing it, then you say import what. So let me make it big, Control plus. So import what? NumPy now. So as np. So I'm going to do our first NumPy now. So if import NumPy, you can just import NumPy like this, fine. But I want to give it an alias like as. I want to also, I can't be typing NumPy every time. I want to name it as np. So that's why we use as. It's in Python. So now let's assume, let me just assume that I have an array like this, x equals to, or let me put it like this. So if you want to do it, you say np now dot, it has a whole lot of, it has, this object now has a whole lot of methods, or methods that you use. You can use it for so many things. Now you just press dot and press space now, tab. You see options that it's going to give you. So the one I'm going to use is array. So I'm going to put array because I want to deal with array now. So you have something like this. So if it's one dimensional, I can just put this one here now. If I just put this one here right now, you see this like zero tensor, that is two dimension. You understand? 0 dimensions. So let me just name it as data and put it here, and then let me print it and see what it's going to give me now. So data, please let me just run print. Let me print data. Okay, so if I run it and see, so this is just one dimension. So this is just one dimension. So if I'm moving away from that now, let's say I have another one, np.array. So just learn how to, that is one dimensional. So see my method. This is a method. Array is a method in an object of np. So I have it like this. So I have, let me just say, because this going beyond just one single dimensions now. So I'll have, let me just say 2, or the even number 4, 6, 8, 10. 10 like this. So maybe I'll save it. Let me save it in let me call it even data, even number. Okay, so I have it here right now. So if I print it now, I say print what's even space even number. So what it's going to give me right now? It's going to give me the numbers. So that is a simple way of using NP, and it's very fast. So there are a lot of other things we are going to look at up to 3 dimensions like that. So we are going to look at that in a subsequent video. I'm just see on the introductory parts, setting it up, importing it, and then using it on 1-dimensional and stuff. So there are a lot of things you are going to do. Something like let me just say that's same data I run now. If you want to run, you can run here, so that's data I run. I can say dot what shape. So if you press tab to, it's going to show you option in case you don't know what to do. Let me just say S now, sh. So it's going to show me shape now. Shape means I want to tell it which kind of dimensions it is. So it's not showing me anything here. That is 0 dimension. You understand? Let me try the other one again. Even number, even number, even number. Dot what let me just see shape now. Understand? So shape is going to tell me. So it's telling me that is what I'll tell you about shape later, but just have a kind of overview of what I'm trying to do. So it's going to show me that this is just 1 dimension. You see, there's nothing here. So, but this dimension has what 5 column 1, 2, 3, 4, 5. So there are 5 columns here. So this is a single dimension. This is 0 dimension. Okay. So we're going to stop here right now. So I'll proceed and I will show you a whole lot on NumPy up to algebraic expressions and some other stuff. Okay, so thank you very much. So we're going to stop here today.